Hi everyone. Thank you for watching the last three lectures. I went through your comments. So somebody asked me to teach you JE questions. I'll do that. In today's class, we'll be doing a bunch of JE advanced questions. And also somebody asked me what's the moment of inertia of a non-uniform rod. So we'll also do that. Today's class is about problems. We'll do some problems based on the concepts we have studied so far. और उसके बाद हमें ये पढ़ना भी have to do the perpendicular axis theorem. Okay, so let's get started. Let's start. First question today is from J Advanced, and let me tell you the specifics of this question. This question is from J Advanced 2011. Okay, four solid spheres, each of diameter root 5 and mass 0.5 kg. Four solid spheres, each of mass, I'll give you the mass. There are four solid spheres and they are placed at the corners of a square. Okay, so there's a square, and at the corners of a square, there are four solid spheres. The mass of each sphere is given, and the size of the square is also given. Okay, so four solid spheres, each of diameter root 5 centimeter and mass 0.5 kg, are placed at the corners of a square whose side is 4 centimeters. If the moment of inertia of the system is n into 10 to the power minus 4, find the value of n. Find the value of n. What are these? These are spheres. The moment of inertia of the system about the center. It's asking you to find out the moment of inertia of this system about the center. Okay? About the center. So right now, if you're solving this video, you should pause it. I've already taught you what to do. You should try it. In case you want a heads up on how to start solving this, keep in mind that these are four spheres. Okay. What you could have is that you could have just one single sphere. What is the moment of inertia of a single sphere? The moment of inertia of a single sphere about its center. Okay, you can never ask what is moment of inertia. What is the moment of inertia about a particular axis? Moment of inertia is not like weight. Like, how many potatoes are there? 4 kgs. ऐसा नहीं है. Moment of inertia of a sphere about its center. So that is equal to 2 by 5 mr square. So for a sphere, about its center, the moment of inertia is equal to 2 by 5 mr square. In this case, you have to take the center of the square, which is at some particular distance. So let that distance be equal to x. So now what you will write? Plus the mass of the sphere multiplied by this additional distance x squared. Why are we doing this? We are doing this because this axis is parallel to this axis at a distance of x. So this theorem is called as your parallel axis theorem. This is your parallel axis theorem. When do we apply the parallel axis theorem? Whenever our axis is not passing through the center of mass, and somehow we can either derive or we can cancel the moment of inertia through the center of mass. In such a case, you apply the parallel axis theorem. So in this question, as you pause the video right now, you have to apply the parallel axis theorem 4 times. Basically, there are four spheres. In this case, all the masses are the same, so you can find out the moment of inertia of one sphere and multiply it by 4. Okay? Pause the video, give it a try. I hope you pause the video, okay? Instead of just continuing to listen the lecture, I hope you pause the video. Let's find out the moment of inertia of a single sphere. Our plan is, the figure that we have is basically 4 times the moment of inertia of a single sphere. So we find out this and then we just simply multiply by 4 because there are 4 of these spheres and all of them are identical. We want to find out the moment of inertia about this center point. So what is the side of the square? The side of the square is 4 centimeters. The side of the square is 4. So I forgot to write that over here. The side of the square is 4 centimeters. So if that is 4 centimeters, the diagonal of the square is equal to 4 root 2. So this distance is equal to 4 root 2 का आधा divided by 2. So this distance is equal to 2 root 2. So first of all, let's find out the moment of inertia of a single sphere, and then you'll multiply it by 4. So that is 4 times of the moment of inertia of a single sphere, which is equal to 2 by 5, multiplied by the mass of the sphere is equal to 0.5. So I'll write it as 1 by 2. Mass of the sphere is 0.5, right? 1 by 2 multiplied by the diameter of the sphere is equal to root 5 centimeters. So the radius of the sphere is how much? Root 5 divided by 2. Keep in mind this is centimeters. So this is into 10 to the power minus 2 meters. समझ में आया? The diameter is root 5. The radius is root 5 by 2. And because it is in centimeters, you have to convert it to meters. So that becomes again into 10 to the power minus 2 and uska square. Plus, what is the mass of the sphere? 1 by 2 kgs. What is the value of x? X is the distance from the center of the sphere to the center of the axis of the square, like this point and that point. That distance is x. How much is that? That is 2 root 2. So half is the mass multiplied by 2 root 2 into 10 to the power minus 2. Iska square. So mx square. Okay. So that is that, and then you add it. This is the parallel axis theorem. This is the main moment of inertia of the object. This one is the moment of inertia of your object, which is called as I0. And that one is the contribution of your parallel axis theorem. So this is your PAT, parallel axis theorem. Now you solve and find out the values. So you have 4. In the first one, I think you can cancel this. So you'll have 1 by 5. And then you'll have multiplied by 5 divided by 4, okay, into 10 to the power minus 4 plus 1 by 2 multiplied by the square of 2 root 2. So that is just 8 multiplied by 10 to the power minus 4. Keep in mind that we have to compare this to what? N into 10 to the power minus 4, which means that the question is saying there is a term with 10 to the power minus 4. You have to tell us what is with that term. You have to divide it into two terms, one with 10 to the power minus 4, and you have to talk about what is with that term, what is with 10 to the power minus 4. So just keeping that in mind, you take 10 to the power minus 4 common. So 10 to the power minus 4 goes common. What are you left with? You are left with 4, and then you're left with this calculation. So 1 by 5 is going to cancel. Keep in mind we have already taken 10 to the power minus 4 common, so we just have 1 by 4 plus 1 by 2 into 8. So what is 1 by 2 into 8? It's just 4, right? And now you multiply 4 with this. So 4 into 1 by 4 is 1. 4 into 4 is 16. 16 plus 1 is 17. So your answer is 1 7 into 10 to the power minus 4 kg meter square. So our answer is n is equal to 17. Given what I have calculated, my answer comes out to be 17. Okay. So what did we do? We found out the moment of inertia of a sphere, which is 2 by 5 mr square. We did not find it out. This thing mostly comes from memory. So keep in mind, you need to basically remember the moment of inertia of all the standard objects. You can't basically sit down and derive it in an exam. It's much easier if you know 2 by 5 mr square. Plus, I recognize that the parallel axis theorem needs to be applied. How did I understand? I understood because the axis is over here, but the center of mass of the sphere is over there. There is a distance between the axis that I want and the center of mass of the sphere. So that is why I immediately understand that I need to apply the parallel axis theorem. And then why did I multiply by 4? Because all of my 4 spheres are identical to each other. So 4 times moment of inertia of each sphere, 2 by 5 m into r square plus the mass, this is half, and then multiplied by distance, which I found out is 2 root 2 centimeters. So I converted that into meters squared. I solved it, I compared it with what is given, and then I can conclude that the value of n is equal to 17. So this question, as you saw it, you can go back and check. This question came in JEE 2011. This is a JEE 2011 question. Like I told you, these questions are not very difficult. They're easy. Please do not have this in mind that it's a JEE advanced question. It's a really awesome question. Nothing like that. The questions are just nice and thoughtful. तुम कर सकते हो. Give it a try. ठीक है? तुम आराम से कर लोगे. Let's try another question. The density of two spheres Okay, the density of two spheres. This is not directly a J advanced question. We'll do the question in a minute. The density of two spheres is rho and 2 rho. Okay, what is this? The density of two spheres is rho and 2 rho. The radius of those spheres is 2r and r. So this is sphere 1 and that is sphere 2. So the densities of two spheres are rho and 2 rho and their radii is 2r and r. The moment of inertia of the first one is equal to n times the moment of inertia of the second one. Find n. The moment of inertia of the first one is n times the moment of inertia of the second one. Find n. So at this point, you're free to pause the video. You should give it a try. With every question I discuss in class, I'm saying this again and again. Pause it, give it a try. One question you might have is, I don't know a formula where there is density. So how do I solve a problem with density? You don't have a ready-made formula, yes, but you can derive a formula where density can have, can be present. So moment of inertia is equal to 2 by 5 mr square for a solid sphere, not for a shell. A shell is an empty sphere. So this is 2 by 5 into mass multiplied by radius squared. So what I will do is we will change the mass. So mass can be written as density, what we want, into 4 by 3 pi r cube. And then you can write the remaining terms as it is. So this is 2 by 5 multiplied by mass multiplied by radius squared. So you can just write this is equal to 2 by 5 into density, again into 4 by 3, again multiplied by pi. So these are all the constant terms multiplied by r cube times r square, which is equal to r to the power 5. So this is your moment of inertia. We want this. Now you write this for I1, you write this for I2, and then you find out the value of n simply by comparison. So I is equal to, okay, you can pause the video now. इसके आगे तुम कर लोगे, तो you pause it and you give it a value on your own. So I1 is equal to 4, you don't even need to multiply. So you can just write 4 by 3 into 2 by 5 into pi. What is the density of I1? That is rho. That is the moment of inertia of the first sphere. What is the radius of that first sphere? That is equal to 2r to the power 5. This is equal to n times the same value for the second sphere. So you'll write 4 by 3 into 2 by 5 into pi. What is the density? The density is equal to 2 rho. And what is the radius? The radius is equal to r. Okay? The radius is equal to r. Again, so you'll write r to the power 5 into r to the power 5. So what will we do? We'll cancel out all the terms. We'll find out the value of n. I think I can already see it that the value of n is 32, but you can calculate. So this term is entirely going to cancel. This is also entirely going to cancel. The value of n is 16. Rho is also going to cancel. So we have 2 times n. On the right side, we have 2 times n. And on the left side, we have 2 to the power 5. Basically because r is also going to cancel. 2r to the power 5 means 2 to the power 5 multiplied by r to the power 5. So r is also going to cancel. So we'll have 2n is equal to 2 to the power 5. Or we can write that n is equal to 2 to the power 4. So 2 to the power 4 is basically 16. Okay, simple question. These are simple numerical questions based on that one was a JEE 2011 question. So this one is based on a JEE Advanced 2015 question. So I did not ask the question to you directly because the direct question is slightly more difficult to what you can handle. The direct question requires some integration. So I modified the question a little bit and I asked you this question. So this is a JEE Advanced 2015 question. Okay, understood n ka value 16 है. That's the second question. So what is the theme so far? We are finding out moment of inertia using what we already know. Let's ask you another question based on the same theme. This question is from JEE 2012 Advanced. I'm asking you the question almost directly. So there is a disk. The question is that there is a disk. And from this disk, we have selected a portion like this. Okay? So there is a disk of radius 2r. The radius of the main disk is 2r. And from this disk, we have selected a smaller disk whose radius is r. This question is in parts. So first of all, if the mass of the bigger disk is m and the mass of the smaller disk is small m, what is the value of m by m? That's the first question. Okay, this question will also help us solve the total question in, like, so the first question is, if the mass of the capital disk is if the mass of the bigger disk is capital M, the mass of the smaller disk is small m, what is the value of m by m? Assuming that the disk is uniform. When you say that a thing is uniform, you mean that the density is not changing. So uniform means density is constant all over the disk. Mass is uniformly spread. Think of a bread and you're spreading the jam uniformly all over the bread. Or if you like butter, you're spreading the butter uniformly all over the bread, everywhere. Or think of a cheese slice. Okay. So m by m, you have to find out the ratio. So what is the value of m by m? Once you have done that, second question. If the smaller disk is placed at a distance of r from the center, so if the smaller disk is placed at a distance of r from the center, what is the moment of inertia of the combination about the center of the bigger disk? What is the moment of inertia of the combination about the center of the bigger disk? So what is the combination? The combination is the bigger disk plus the smaller disk, both of them put together. Okay. So if you have any ideas on this thing, right now you can pause. You can start. I'll continue telling the answer. So the beauty of a recorded lecture is you can pause it and you can just start on your own. First of all, let's start let's try this first part. What is the value of m divided by m? One key idea over here is that the mass is spread over an area. So the mass is proportional to the area of the disk. Obviously, it's proportional to the thickness, but I told you both the disks are identical and we are selecting a part of that disk. So both of the parts have the same thickness. Okay? Just to be very clear, we are assuming that both of them, they have the same thickness and mass is proportional to area, or therefore mass is proportional to area. So we can write for the smaller disk, m is proportional to pi r square. What is the area of a circle? Pi r square. So a disk is basically a circle, right? So the area is equal to pi r square. Now for the bigger one, that is 2r. So we can write capital M is proportional to pi into 2r squared. Keep in mind, whenever you divide two proportionality equations, it becomes an equality. So if you write m divided by m, the two proportionality signs will become an equality sign. When you're dividing two proportionality equations, it becomes an equality. The pi is going to cancel. So you're going to write r square divided by 2r squared, which is equal to 4r square. तो अब क्या लिखेंगे? The r square is going to cancel. The value of m by m is equal to 1 by 4. So that's the first thing we wanted to find out. So because it's a JEE mains question or it's a JEE advanced question because it's a numerical question, if you're asked about this, you should write the answer as 0.25. Always remember to write your answer in x dot yz format. So this is your x and that is your yz. So x, y, and z are not variables, but your format required by JEE mains or JEE advanced is that after the decimal point, there should be at least 2 digits of precision. So that is what it is, 0.25. Okay, keep this in mind. Practice rakhoge to exam mein problem nahi jayega. Otherwise, in an exam, you're going to sit down and wonder what is 1 by 3. 1 by 3 is 0.33. You should know that. Okay, so m by m is 1 by 4. The first part is over. For our further calculations, we will need to say that small m is equal to capital M divided by 4. That's for our further calculations. Now, how do you find out the moment of inertia of the combination? In our combination, when you write down I0, the moment of inertia of the bigger disk plus the smaller disk, the moment of inertia of the bigger disk is simply equal to half mr square. How can I say the moment of inertia is half mr square? First of all, because it is a disk. And secondly, our axis is about the center of that disk, which is the center of mass, right? So about the center of mass, you don't need to do any calculation. You can just write half mr square. The problem lies with the smaller disk. For the smaller disk, which I have shown there, so the moment of inertia of that small disk is equal to half mr square. That small disk is in pink, so is the term over here. So that is half mr square. Keep in mind that the smaller disk is at a distance of r. So you need to add an additional mr square to this to get the actual moment of inertia. So that is half mr square, because the moment of inertia of that disk is half mr square. It is also at a distance of m, like it is also at a distance of r. So you will have to multiply m with r square and you have to add that. So that is your parallel axis theorem. This is your parallel axis theorem. This is your main moment of inertia, and this is also your main moment of inertia. Now you write out the values. So you will get 1 by 2 multiplied by m multiplied by r square plus 1 by 2. Don't write small m because small m is not given to you. So you write capital M divided by 4 multiplied by r square plus again capital M divided by 4 multiplied by r square. So this thing will become 3 by 2 into m by 4. So this will become 3m divided by 8. You can try it on your own. Okay, this is 3m by 8 r square plus this one is 1 by 2 mr square. So 1 by 2 is 4 by 8 plus 3 by 8, which is equal to 7 by 8 mr square. So I did not ask it to you in a format where it's a numerical question, but if I asked you that I is equal to n times mr square, what is the value of n? Then you would divide 7 by 8 and you would find out the value of n. Okay, that will be 0.87 something. So the value of n will be that much. समझ में आया? Did you understand the calculation? So that will be 0.875. Okay, 125 into 8 is like basically 1000. So you can just multiply 7th with 125, which will just give you 0.875. The value of n is 0.875. Okay. Now the point is, how did we solve the question? We first of all found out m by m, saying that mass is proportional to area. Okay, yeah, this is very straightforward. Second thing is moment of inertia of the bigger disk plus the smaller disk. So you have to add the moment of inertia. Just to remind you, when can you add? You can add whenever the axis is the same. So what is the axis over here? The axis over here passes through the center of the bigger disk. So simply you need to find out the moment of inertia of the bigger disk, which is half mr square. Add with it the moment of inertia of the smaller disk, which is small half mr square. But if you don't add mr square, what does that mean? If you do not add this mr square, then that means that the bigger disk and the smaller disk both have the same axis, which is this problem. So in a problem like this, you would write capital half, like m into capital, like capital mr square plus half into small mr square. So that is for this problem. Here, the axis of the bigger disk and the smaller disk are the same. There is no distance, so you can directly write it. But in this problem, there is a distance between the two axes, so you have to apply the parallel axis theorem, and then you get the answer. Okay? समझ में आया? Let's try another question. So this was the third question today, I guess. So let's try another one. Today is all about questions, lots of questions. You studied some theory, so today you try questions and see how much you understood. Take a square. Okay, keep in mind the moment of inertia of a plate, rectangular plate, which is also known as a rectangular lamina, is 1 by 12 m a square plus b square. So this is a square plate and this is a semicircle. Okay, this is a square plate and that is a semicircle. Both of them, they have the same density rho. A square plate and a semicircle have the same density rho. Find the moment of inertia of the system about, find the moment of inertia of the system about this point, about the midpoint of the edge joining the semicircle with the square. Find the moment of inertia of the system about the midpoint of the side joining the semicircle and the square. So what do you have? You have the moment of inertia of a square. In addition to that, you have the moment of inertia of a semicircle. You need to find out the total value. Given that the density is rho and the length of the radius of the semicircle is r. The density rho is given, radius r is given. Give it a try. Pause the video and you try. I taught you how to deal with how to deal with density, how to deal with volume, how to deal with mass. Basically, density is equal to mass divided by volume. Okay. By the way, one thing to tell you over here. Here the density is what is called as a mass per unit area. So here the density that is given to you is a mass per unit area. It is not the standard kind of density that you're accustomed to. This is a mass per unit area density. What does that mean? That means that if you want to find out mass, you don't have to multiply with volume. You just have to multiply with area. Okay. So if you multiply with area, you will get your mass. So it is called as a mass per unit area. This is not a very absurd concept. For example, if you take up if you take up a small curtain in your house, or if you take up a bed sheet in your house, that bed sheet is going to have a particular amount of weight. It's very light. But if you pick up a blanket, or if you pick up like two blankets of the same size, a bed sheet and blanket are almost of the same size. A blanket is far more heavier than a bed sheet, right? So it has a higher mass per unit area. For the same area, its mass is higher. I think you understood the concept. Now, pause the video, give it a try. What I would do here is, first of all, I need to realize axis is here, whereas the axis of the square, the center of the square is somewhere else. The center of the square is like somewhere over here. So you draw one diagonal over here, you draw one diagonal over here. The center of my square lies over here. So first of all, I have two axes. Whenever I have two axes, they are parallel to each other. I can apply the parallel axis theorem. What is this distance? This distance is obviously equal to r. Okay, this distance is r. You can see it. This is also r. That is also r. The side of the square is obviously 2r. So that distance is equal to r. Now what I'll do is, I'll first of all write this thing out step by step. So I0 is equal to moment of inertia of my square plus moment of inertia of my semicircle. To find out the moment of inertia of the square, I'll apply the moment of inertia of the rectangular plate, which is equal to 1 by 12. I don't know the mass, so I'll just write the mass of the square is capital M. Let us say the mass of the square is capital M. Let us say the mass of the disk is small m. We'll put in the values. Multiplied by a square plus b square. The moment of inertia of a rectangular lamina of size A by B is equal to 1 by 12 m times A square plus B square. So what is A? 2r. What is B? B is also equal to 2r. So you will write 2r squared plus 2r squared. So 1 by 12 m A square plus B square. Also keep in mind that the parallel axis theorem has to be applied. So this is equal to m into r squared. So that is the moment of inertia of my main square. This is the moment of inertia of my square. This is the parallel axis theorem part. Okay. Next, what about my semicircle? So keep in mind, a semicircle is basically half of a full circle. है ना? Half of a full circle is a semicircle. So if you want to find out the moment of inertia of a disk, the moment of inertia of a disk is equal to half mr square. Half m, where m is the mass of the total disk, r square. If you followed my last lecture, I told you that if you take a part of a disk, then for the part also, because the shape is the same, the moment of inertia is still half mr square, whereas the mass is the mass of only the small part. So this is the mass of the small part, not the mass of the total disk. So in this case, we have taken the mass of the semicircle as small m. So the moment of inertia of this small semicircular part, the disk part, is equal to just half m r square. Why didn't we add anything? Because our axis matches with the axis of the disk. No need of parallel axis theorem. Okay, I hope you understood till this point. The only thing remaining for us to do right now is to find out the value of capital M and small m and just substitute in the equation. To find out mass, always write mass is equal to density multiplied by area. So I have to find out the area of the square, which is very simple, 4r square. For the small m, I can write rho. The mass of a total disk would be for pi r square. I need to find out for half of a disk. So for half of a disk, I'll write pi r square divided by 2. Put these values back in the equation. Solving and then put these values together. So this will be equal to 2r square, 4r square plus 2r square, 4r square, 4r square plus 4r square is 8r square. So this is 8m divided by 12. 4 2s are 8, 4 3s are 12. So this is 2 by 3 mr square plus mr square. So 2 by 3 plus 1 is equal to basically 5 by 3 mr square. That's the first term. Plus 1 by 2 small m capital R square. Now I'll continue on the right side. So put the value of capital M. So this is equal to 5 by 3 into rho into 4r square. That is just the value of M. Again multiplied by r square. So that's the total value. Plus 1 by 2 small m r square. So rho into pi r square divided by 2 again multiplied by r square. Don't forget the again r square. ठीक है? So this is your term. इसके आगे तुम्हें पता है, you don't need my help. Take the rho, take the r to the power 4 and take it common. Rho r to the power 4. So just put the remaining terms together. 5 fours are 20. So you'll get 20 divided by 3 plus you have pi divided by 2 divided by 2. So you have pi divided by 4. So 20 by 3 plus pi by 4. That's your answer. So if this was a numerical question, what you would do is you would put the value of pi, which is 3.1415, and then you would write 20 divided by 3, which is 6.66, and then you would divide pi by 4 and you would add both of them and you would find out rho r to the power 4. Okay? Always keep in mind that you will have to calculate things in decimal form. So 20 by 3 is like approximately 6.66. What is pi by 4? The pi is 3.1415. Okay? The value of pi is 3.1415 and you have to divide that by 4. So 3.1415 divided by 4. So how much will you get? You will get 4 sevens are 28, 3 bachega, 4 eights are 32, 2 bachega, 4 fives are 20. This is more than sufficient for us. So 6 plus 5 is 11, 1 plus 6, 7 plus 8 is 15, 1 plus 6, 7 plus 7 is 14, 7.451. Rho r to the power 4. So if they ask you the moment of inertia of this thing is equal to n rho r to the power 4, what is the value of n? The value of n is 7.451. Keep in mind, the mains exam asks you always in x dot yz. You truncate, you cut off whatever is beyond dot yz. So after z, even if you had a 7 over here, you may or you may not round off. That's up to you. Even if you round off, even if you don't round off, both ways your answer is going to be marked correct. In this case, you just truncate, you cut it over here. Okay, you just basically cut your answer over here, and then you answer as 7.45. That's your answer. Okay. So I hope you understood this question. Try another one. Today is all about questions. So in this question, exactly like the last one, I want you to pause this right now and like try it on your own. We have the exact same square plate, exact same to same square plate. Except what we are doing is instead of adding a semicircular plate, for the first time, we are going to cut out a semicircular part. So I'm going to remove the semicircular part. So you take a scissor over here and you cut out the semicircular part and you remove it. Okay. So everything is the same. This is equal to 2r. That is the axis about which you need to find out the moment of inertia. Find the moment of inertia about the point O. Okay. Pause the video right now. Everything is given to you. Same as in the last problem. The mass per unit area is rho. What is rho? Rho is mass per unit area. इसका मतलब क्या है? If you multiply rho with area, you will get your mass. Pause the video, give it a try. How would I solve it? I would say that just like in the previous problem, if I added, if I like, if over here I took a disk and I added the disk over here, what would I say? Moment of inertia is equal to moment of inertia of the square part, I of the square part plus I of the semicircular part. So I would write I of the square part plus I of the semicircular part. Now I am not adding, I am actually subtracting, I am removing a part of it. So what I will do is I will write minus sign over here. That is your first idea. Because you are cutting a part of the disk out. So cutting basically means subtracting. When you are joining something, when you are adding, that is obviously plus sign. So when you are adding something or basically when you are joining something, then you would write, okay, then you would write a plus sign. इतना कॉन्सेप्ट समझ में आया? If you could not think of this much, now I've told you. अब एक और बार try करो. Try to pause the video and give it a try. बाकी what is the moment of inertia of the square? The moment of inertia of a square is equal to 1 by 12 into m into 2r square plus 2r square. ठीक है, this is clear to you. This is the moment of inertia of a square about its center. But we are not at the center of this square. We are at a distance of r from it. So you will add an additional mr square to it. That is your first part. What is the mass m? M is the mass of the square before cutting. M is the mass of the square before cutting. Also, we will have small m. The small m is the mass of the small circular part that you are cutting out. So it is the mass of the cutout. What do we have to do? We have to subtract. Can we directly write half mr square? Yes, because we don't have to switch to any other axis. It is a part of a disk of the same shape. So you can just directly write half mr square. Done. Now what do we need to do? Just like in the previous problem, we need to calculate all the values. So let's go back to the previous problem for a minute. We got 5 by 3 mr square. We got 1 by 2 mr square. Over here also, if you see all the terms, everything is the same except you have a minus sign. So you will simply write 5 by 3 mr square minus, not plus, minus half small mr square. So basically what I wanted to teach you was the idea of this minus sign. Understand that we are writing a minus sign because we are cutting something out. If you are adding something, you would write a plus sign. If you are cutting something out, you will write a minus sign. समझ में आया? ठीक है, अब इसके आगे ज़्यादा कुछ नहीं है. Just do the calculation just like before. Instead of rho r to the power 4, 20 by 3 plus pi by 4, now you will get rho r to the power 4, just like the previous problem. You will also get 20 by 3 because all the values are same, minus pi by 4. ठीक है, तो इसके हिसाब से you can calculate and find out your answer. I hope you understood the idea of cutting something. So now that we have understood cutting, let's try another problem. ठीक है, you've understood this. I explained to you कैसे cut करते हैं, कैसे add करते हैं, कैसे subtract करते हैं, when you add, when you subtract. So now let's try another one. Let's take a disk. ठीक है, and in this disk, what I'm going to do is, at the center of the disk, I'm going to cut out a small part. The mass of the bigger disk is obviously capital M. The mass of the smaller disk is small m. The first question I'm going to ask you, this is related to the disk problem. This is 2r. This is small r. What is the value of m by m? First of all, what is the value of m by m? Once you're done with that, what is the moment of inertia of this system? What is the moment of inertia of the system about the center of the bigger disk? You are cutting two disks with their centers same. So such a thing is called as concentric, which means that their centers are the same center, concentric. So now I'm asking you, what is the moment of inertia of the system about the center O? So how will you find out m by m? You will use my logic, the idea that mass is obviously proportional to the area. So because mass is proportional to the area, m is proportional to pi r square. Capital M is proportional to pi into 2r ka square, 2r squared. Therefore, the ratio is equal to 1 by 4. We already knew this. So the m by m is equal to 1 by 4. Now, coming to the second part. What is the moment of inertia after I cut out? So moment of inertia is equal to moment of inertia of the bigger disk minus the moment of inertia of the smaller disk. Understood? The moment of inertia of the bigger disk minus the moment of inertia of the smaller disk. Why did I put a minus sign? The minus sign is only there because you cut something out. काट रहे हो किसी चीज को, that is why there is a minus sign. अब फटाफट लिख दो, डिस्क का मोमेंट ऑफ इनर्शिया कितना होता है, हाफ इंटू कैपिटल एम इंटू रेडियस का स्क्वायर 2r squared minus, no need of parallel axis theorem because the axis is the same, minus half into small m into the radius of the smaller disk is equal to r square. That is equal to half into m into 4r square minus half. What is the value of small m? M by 4. So into m by 4 into r square. नहीं दिया वैल्यू, यहाँ पे वैल्यू अपन ने निकाला m is equal to m by 4, so we can use that value over here, m by 4 r square. फटाफट m into r square को कॉमन ले लो, so m into r square is common. What is half of 4? Obviously 2. What is 1 by 2 into 1 by 4? That is equal to 1 by 8. So what is your value? Your value is equal to 15 by 8 mr square. Your answer is 15 by 8 mr square. समझ में आया? So you have a big disk, you have a small disk. You have to calculate bigger disk minus smaller disk. So instead of adding it up, now you're going to subtract. Okay, I hope you're clear. Let's try another problem. I hope you're not suffocated by the number of problems we are doing today. Do let me know, okay? First of all, physics is a little bit of theory. Thoda theory samajh mein aaya, you can start doing problems. There's no need of additional help. You don't even need my help. You can do it all on your own. Try another problem. Let us say we have a disk. Okay, again, same kind of problem. You try this on your own. We have a disk, and from this disk, we are cutting a smaller disk from the edge. From the bigger disk, we are cutting a smaller disk from the edge. The problem as it is right now is a JEE Advanced 2012 problem. This is the exact problem that was given in 2012. So this radius is equal to 2r. That is also equal to 2r. So my disk is actually looking a little bit small. I should have drawn it a little bit bigger. So this is 2r, and that radius is also like, that is also 2r. Iska bhi distance is also 2r. So the question over here is, a lamina is made. A lamina matlab flat sheet. Keep this word in your mind. You will come across it a lot in this chapter. A lamina means a flat sheet. Okay? A flat two-dimensional sheet. A lamina is made by removing a small disk of diameter 2r from a bigger disk of radius 2r. The moment of inertia of this lamina about O. The moment of inertia of this lamina about O. It is also asking you about a point P. So we will talk about a point P in some time. So it's asking you about two things. First of all, you find out the moment of inertia about O. We'll talk about the second part in just a minute. The second part is that there is a point P and you have to find out about point P as well. Also about point P. तो अपन वो 1 मिनट में करते हैं. First of all, you pause the video. फटाफट पता कर लो IO का वैल्यू क्या है. So what is the value of IO? IO is the moment of inertia of the bigger disk minus the moment of inertia of the smaller disk, because you are cutting this part out. You are removing this part. So you will write IO, the moment of inertia of my object is now equal to the moment of inertia of my big disk minus the moment of inertia of the small part that I'm cutting and removing. So what is the moment of inertia of my big disk? About this center, by the way, about the point O. So moment of inertia of my big disk is equal to half into capital M. The capital M, I don't know. So let's say that this mass is equal to capital M. This is small m. You can assume these values. That's not a problem. So that is equal to capital M into the radius, which is equal to 2r squared. So half m r squared. That's the moment of inertia of the big disk. What do you have to do? You have to subtract the moment of inertia of the smaller disk, which is how much? That is equal to half into small m into what is the radius of this disk? This radius is obviously equal to r. So half into m into r square. The moment of inertia of the bigger disk is equal to half into capital M r square, and this one is going to be small m into r square. But you need to apply the parallel axis theorem because there is a distance between these axes, and that is equal to r. So plus m r square. Keep in mind over here, even if you are cutting out a part, parallel axis theorem applies to the cutout part as well. Parallel axis theorem applies to every part wherever needed, whether you are adding or whether you are removing. So whether you are joining the part or you are cutting the part, the parallel axis theorem anyway applies. समझ में आया? तो इस पार्ट को हम लोग कट आउट कर रहे हैं फिर भी और अप्लाइंग द पैरेलल एक्सिस थ्योरम ऑन इट. सो नाउ यू कैन जस्ट प्रीटी मच सॉल्व फटाफट जैसे अपन को आता है. We already know from so many times calculating this problem that m by m is equal to 1 by 4. No need to discover that fact once again. So you can just write half into m into 4r square minus, so this is 3 by 2 mr square, so 3 by 2. What is the value of m? M is equal to m by 4, so into m by 4 into r square. So I can just basically say that, like, mr square is common. So half of 4 is 2, minus 3 by 2 into 1 by 4 is basically 3 by 8. 8 2 is 16, 16 minus 3 is 13. ये हो जाएगा 13 by 8 mr square. समझ में आया? So we are we are over here right now. Where did we start the class today? We started the class today by simply finding out the moment of inertia of one thing and another thing. Right now we are solving this question, जहाँ पे एक डिस्क का पार्ट हम लोग कट आउट कर रहे हैं फ्रॉम अ बिगर डिस्क, एंड यू अप्लाई द पैरेलल एक्सिस थ्योरम टू द कट आउट पार्ट. Okay. At this point, I'm going to take a pause. You think about what is the other part of this question. The question is actually asking you, what is the ratio of IP by IO? So what is a point P? A point P is this point that is shown over here, 90 degrees paise. Like, this is the top part, that is the horizontal part, this is point P. The question is asking you, what is the moment of inertia about P and moment of inertia about O ka ratio? What is the ratio of IP divided by IO? So when you find out the ratio, you will find that the mass cancels out. That is why the original question that is there doesn't give any mass. Okay, so if something is not given, what you can do is you can just like assume it. In the end, it's going to cancel out. That's why it's not given. So Karu, you solve it. I'll remove some of my workout from here, and I'll wait for you to solve it on your own. Video ko pause kar do. You can do this. Give it a try. Okay, so I have to solve it for you now. How do I solve it? First of all, let's just clean up the figure a little bit. This is R. You already know that is R. We also know a little bit about this is M, that is R. ये सब हमें पता है. Let's clean up the figure थोड़ा सा. Let us also remove this value from here. Let's remove all of this clutter. This is done. Now, let's start. This is the center of my disk. Of the bigger disk, this is the center. Of the smaller disk, that is the center. This point over here, this is the center of the smaller disk. So what is the distance that we want? The distance that we want is this distance. Keep in mind that our axis is not the axis of the bigger disk or even the smaller disk. Both of them this is not the axis. So let us say this is R2, the distance to the smaller sphere. Let us say this is R1, the distance to the. Now you want me to find out the moment of inertia about P. So moment of inertia about P matlab IP is equal to moment of inertia of the bigger disk again minus moment of inertia of the smaller disk. So what is the moment of inertia of the bigger disk? The moment of inertia of the bigger disk is usually half mr square. It's a disk, so it is half mr square. Just keep in mind that this disk, the axis is different. The axis is at the edge of the disk. So this is half mr square, but parallel axis theorem has to be applied. Over what distance? R1 is equal to 2r. So you will have to add m into 2r squared. Which mass? Mass of the original disk, not after cutting out. Original mass of the disk, mr square. Why are you not using the cutout mass? Because we are cutting it out as a part of our calculation. Our calculation itself is cutting it out. So we don't have to do anything else. This is the original moment of inertia of the disk. And this is your parallel axis theorem part. So this is your PAT part. And this is your I0 part. Now you will have to subtract. So same thing you have to do for the smaller disk. What is the moment of inertia of the smaller disk? That is equal to half into mr square. Now you will have to you have to add the parallel axis part. So you will have to write m into r2 squared. R2 के लिए you will have to do some calculation. So you take this right angle triangle. This is r, that is 2r. So you can write over here r2 square is equal to perpendicular square plus base square. So that is 4r square, which makes it 5r square. So we can take this value and we can put this value over here. So we can just basically write m into r square plus m into 5r square. समझ में आया? अब इसको अपन कैलकुलेट करते हैं. तो फर्स्ट ऑफ ऑल लेट्स रिड्यूस बोथ द पार्ट्स. So upper part you will have half mr square plus 4r square. The 4 plus half is how much? 2 into 4, 8 plus 1 is 9 by 2 mr square. That is for the first part. You will be subtracting this part from it. So you will be writing 1 by 2 plus 5. 2 5s are 10 plus 1, 11 by 2 into small m into r square. अब इसको तुम्हें subtract करना है. तो कितना हो जाएगा? दैट विल बी इक्वल टू 9/2 mr² minus 11/2 into the value of small m is equal to capital M divided by 4 multiplied by r square. So 2 fours are 8, 9 fours are 36, minus 11 is equal to 25. So 25 divided by 8 mr square is the value of IP. ये IP का वैल्यू है 25 by 8 mr square. What is the value of IO? IO is equal to 13 by 8 mr square. So what is the value of IP divided by IO? That is equal to mr square. Mr square is going to cancel. 25 divided by 13. The value of IP divided by IO is equal to 25 divided by 13. What is it to the nearest integer? This is a time in J when they were asking you to calculate to the nearest integer. The question is asking you what is the value to the nearest integer. Calculate this to the nearest integer. You can already guess the answer. I'm just emphasizing it. It is asking you to calculate to the nearest integer, not to truncate. So to the nearest integer, this is 2. The answer to our question is 2. Okay. So this is, by the way, how an advanced question looks like. So we have covered a few questions over here. आज का क्लास का दूसरा पार्ट ये था कि आई वांटेड टू टॉक अबाउट द परपेंडिकुलर एक्सिस थ्योरम. आई आल्सो वांटेड टू find out the moment of inertia of a non-uniform, but it doesn't look like I'll have sufficient time for that. We'll see in the next class. If I can't do it today, we'll do it in the next class. Leave your suggestions in the comments so that I can better suit this needs. The next topic today is the perpendicular axis theorem. Perpendicular axis theorem. Perpendicular axis theorem क्या है? When is it applied? So perpendicular axis theorem applies first of all to only two-dimensional objects. Keep in mind this condition. It only applies to two-dimensional objects. It only applies to two-dimensional objects, 2D objects. It does not apply to three-dimensional objects. It applies to two-dimensional objects. Okay. So what is that? Such objects are like disk. It will apply to a ring. It will apply to a plate. It will not apply to a shell. A shell is not a two-dimensional object. It is a three-dimensional object. Anything that is two-dimensional, it will apply to such objects. Okay, it will apply to a thick plate also, thin plate also, rectangular plate, triangular plate, circular plate, whatever kind of plate, it will apply to a plate. So what is the theorem? The theorem states that if you take a rectangular object or any kind of a object which is two-dimensional, important thing is length or breadth hona chahiye. It's a two-dimensional object. And then you find out the moment of inertia about one axis. Let us say this is Ix. And then you find out the moment of inertia about some other axis. Let us say that is Iy. Then the moment of inertia about the third axis. The moment of inertia about the third axis. Okay? The moment of inertia about this axis, Iz, is given by Ix plus Iy. बात समझ रहे हो? The moment of inertia about an axis that is perpendicular to the plate. The moment of inertia, I'll write it. The moment of inertia, this is the theorem over here. The moment of inertia about an axis perpendicular to a plate. Perpendicular to a plate is the sum of moment of inertia of two mutually perpendicular axes. Mutually perpendicular समझ रहे हो? Mutually perpendicular axis. Mutually perpendicular means 90 degrees between these axes. So basically there is a 90-degree between everything. That is why it's called as perpendicular axis theorem. There is a reason I wrote x, y and z. So it is all the things are perpendicular to each other. So the moment of inertia is the sum of moment of inertia of two mutually perpendicular axes lying in the plane of the plate. lying in the plane of the plate. Instead of a long definition, just see what I'm saying. Iz is equal to Ix plus Iy. So can you say Ix is equal to Iz plus Iy? No, you cannot say that. That's wrong. Why? Because Z and Y are not lying in the plane of the plate. So that is why it is wrong. So only thing you can say is Iz is equal to Ix plus Iy. Okay. So what is the application of the perpendicular axis theorem? The application of the perpendicular axis theorem is like many problems it's used. One of the easiest places where it is used, or one of the best places where it is used, where I can show it to you, is in the case of a rectangular plate. Take a rectangular plate. I'm showing the plate to you head on, like you are seeing it from the front. Imagine a copy or a book. Now you imagine that you are seeing this plate from one side. So if you're seeing this plate from one side, you will see that this plate has some length. Okay? This plate is going to have some length. It is also going to have some thickness. So to you, the plate will look like this. So it will look like a rod. So let us say the length of this is B, then this will look like a rod of length B. If you look at the same plate from the top side, if you look at this plate from this side, then this plate is going to look at look like a rod to you, and its length is going to be A. We are interested in finding out what is the moment of inertia of this plate about its center. So that is now equal to, because of the perpendicular axis theorem, that is equal to the moment of inertia about this axis plus the moment of inertia about this axis. समझ रहे हो? It is equal to the moment of inertia about the vertical axis plus the moment of inertia about the horizontal axis. So for the vertical axis, what will you write over here? It is a rod. So the moment of inertia about the vertical axis is 1 by 12 ma square. For the horizontal axis, for the, follow the direction of rotation like I've shown, that is equal to 1 by 12 m into b square. So what is the moment of inertia of my total square plate? So moment of inertia of my plate is equal to moment of inertia about the vertical axis plus the moment of inertia about the horizontal axis. So this is your horizontal axis plus the moment of inertia about the vertical axis. So both of them put together, you will get your value. So ये कितना हो जाएगा? 1 by 12 m into a square plus 1 by 12 m into b square. So how much is that? 1 by 12 m into a square plus b square. Proved. Okay. So moment of inertia of a square plate or any plate, a rectangular plate, is 1 by 12 m a square plus b square. That's the proof. Okay. So this is your proof. Perpendicular axis theorem की और भी like applications हैं. Another application of the perpendicular axis theorem is this, that if you are given a disk, for example, this is a disk. What is the moment of inertia if the disk is tossed? Matlab about an axis passing through the plane of the disk. So find the moment of inertia about an axis passing through the plane of the disk itself. So this is one axis. You will have to imagine your second axis. The second axis has to be perpendicular to the first axis. This is your second axis. Now you will have to think about a word that is called as symmetry. What does symmetry mean? Symmetry means that some things are same. So what I'm saying is the first axis is the same as the second axis. Both of these axes are the same. So if my moment of inertia is I, then here also my moment of inertia is I. So what do I know about the disk? I know that the moment of inertia of this disk about its center is equal to 1 by 2 mr square. Now because of the perpendicular axis theorem, I know that this is equal to moment of inertia 1 plus moment of inertia 2. Axis 2 and axis 1. Both of their values are same because of symmetry. So because of symmetry, I can write that this is equal to 2i. Get the ideas first. How could I write this? I could write it because of the perpendicular axis theorem. Now, because I know that the disk is symmetrical, which is your second idea, this is your second idea, I use the symmetry of the disk. So I could say that that is equal to 2i. So now you can write half mr square is equal to 2i. So 1 by 4 mr square is equal to I. So what is the moment of inertia in the plane of the disk? That is equal to 1 by 4 mr square. So that's it for today. Let's not overload you with more problems. Try to figure out what we did in today's class. Try to practice it once again on your own. See you again in the next class. Let me know what you understood and what you did not understand. You can leave some comments so that I can like make the next lecture accordingly. Have a great day.